Hi viewers, welcome to my tutorial class on composite bars. Today I will work out another example on composite bar. 3 bars made of copper, zinc and aluminum are of equal lengths, have cross sections 500, 800 and 1200 square mm respectively. They are rigidly fixed at the top and are connected to a crossbar at the bottom. Find the stresses induced and the load shared by each material when subjected to a downward pull of 300 kN at the bottom. Assume the crossbar remains horizontal even after the pull is applied. Given EC is equal to 120 GPa, EZ is equal to 100 GPa and EA is equal to 80 GPa. So 3 rods fixed at the top and is connected to a crossbar at the bottom. The crossbar is initially in the horizontal position. All the bars are of equal length and the load is applied on the crossbar in such a way that crossbar remains horizontal even after the load is applied. So in that case, all the 3 bars has to elongate equally to keep the crossbar horizontal. So from that we understood that the elongation produced in copper, zinc and aluminum, all of them are equal. Question is to find out the stresses induced and load shared by all the materials when it is subjected to a downward pull of 300 kN. Young's modulus of all the materials are given and the area of cross sections are given. We have to find out the stresses and the load taken by all the 3 different materials. These are the given data. Area of copper is 500 mm square. Area of cross section of zinc is 800 mm square and for aluminum it is 1200 mm square. The downward load is 300 kN, that is 300 into 10 raised to 3 Newton, and Young's modulus of copper is 120 GPa, so that is 120 into 10 raised to 3 Newton per mm square. Similarly, EZ is 100 GPa and EA is 80 GPa, so we can convert into Newton per mm square. Now we know that crossbar is in the horizontal position even after applying this load. So that means elongation in copper, zinc and aluminum, they are equal. And these elongations are in equal lengths of bars. All the bars are of equal length. So the elongation produced are equal and lengths are also equal. So that means equal elongation in equal lengths or strains in all the 3 materials are equal. So strains are equal. So we know the strain induced in copper is sigma C by EC, strain induced in zinc is sigma Z by EZ, and strain induced in aluminum is sigma A by EA. So all strains are equal. So we have the relation deformations, that is elongations are equal. Since the lengths are equal, even the strains are equal. So you can equate the strain induced in all the 3 materials. Now from this you can get the relationship between stresses. There are 3 different unknown stresses. Using this relation we can reduce it into single unknown. By taking first and last part of this equation, you can take sigma C is equal to EC by EA into sigma A. Taking the first term and last term, sigma C is equal to EC by EA into sigma A. So I am expressing everything in terms of stress in aluminum. So sigma C I should express in terms of sigma A. Even sigma Z I should express in terms of sigma A. So you can take this first and last term and again to get the next relation, second and last term. So sigma C is EC by EA into sigma A and EC we know 120 into 10 raised to 3 and EA is 80 into 10 raised to 3. So from that you get 1.5 sigma A. So sigma C is 1.5 sigma A. That means stress induced in copper has to be 1.5 times the stress induced in aluminum. When the load is applied, the stress induced in copper will be 1.5 times the stress induced in aluminum. Now also this relation we can take sigma Z by Ez is equal to sigma A by Ea, or sigma Z is equal to Ez by Ea into sigma A. Ez is 100 into 10 raised to 3, Ea is 80 into 10 raised to 3. So this will give 1.25 sigma A. So sigma Z is equal to 1.25 sigma A. So that means stress induced in zinc is 1.25 times the stress induced in aluminum. So you can express the stress induced in copper and stress induced in zinc in terms of stress induced in aluminum. So I am getting only one variable, sigma A. Now to solve for sigma A, you can use this relation. The total load is taken by all the three rods, PC plus PZ plus PA. The load taken by copper, load taken by zinc and load taken by aluminum, all the three together is supporting this load 300 kilonewton. So we have this relation, and also we know PC is sigma CAC, PZ is equal to sigma ZAZ and PA is sigma AAA is equal to P, which is 300 into 10 raised to 3 Newton. 300 kilonewton, so 300 into 10 raised to 3 Newton. Now you can substitute for sigma C as 1.5 sigma A, sigma Z as 1.25 sigma A. I am expressing everything in terms of sigma A. So there will be only one unknown, sigma A. Substitute for AC as 500 and AZ as 800 and AA as 1200. Now you can solve for sigma A. Sigma A is 101.69 Newton per mm square. So you are getting the stress induced in aluminum. So once you get that value, you can find out the stress induced in copper using the earlier relation 1.5 sigma A, that is 1.5 into this value, you get 152.54 Newton per mm square. Also stress induced in zinc is 1.25 times sigma A, or 127.12 Newton per mm square. So you got the stresses in all the materials. Now you can find out the load shared by each material. Load shared by copper is sigma CAC, and we know the stress in copper, and area is also known. You can multiply that, which will give the load taken by copper rod. So that will give 76.27 into 10 raised to 3 Newton, or 76.27 kilonewton. And also the load taken by zinc is sigma ZAZ. Sigma Z is 127.12 into the area is 800, so which will give 101.7 into 10 raised to 3 Newton, or 101.7 kilonewton. Now to find out the load taken by aluminum, that is last material, you can either go for sigma AAA. You have to multiply the stress with the area of aluminum, that will give the load, or you can subtract from the total load. Already the load taken by copper and zinc are known, so total load is also known. So total load minus load taken by copper and zinc has to give the load taken by aluminum. So you can also do that. P minus PC minus PZ will give the load taken by other material, that is aluminum. So which will give the same value as this, 122.03. So we got the stresses induced in all the materials and also the load taken by three different materials. So that's all for today. Thank you for watching.